All right, hello people watching this video. We're going to start to do review for chapter 7. And we have proportions, mean, standard, or variance and standard deviation that we're doing. Those were section 7.1, 7.2, 7.3. I'm going to do 2 boxes for each one because you don't have to write these off to the side. But if it helps you to organize your thoughts, there's that. We're going to have 2 boxes for each one because in the one, we're going to do the confidence interval, and the other one, we're going to do how you solve for n, right? N is like, how many people do you have to sample in order for the error to be this, okay? So that's going to be each one of these second rows here, okay? All right, so first things first, when we're doing proportions, proportion is like the percentages, okay? That's going to be probably one of the hardest things is on the review and on the test is to distinguish between them and like, are you doing means? Are you doing proportions? Which one are you doing? So proportions have to do with percentages. If you want to write that in there, you're looking for percent. And important information. I'm going to talk about the variables that we need to know for proportion. Does somebody have their notes handy? I'm going to steal yours, just to make sure that I'm writing all this stuff in right. So things that we know that we need for proportions are, we know we need n always. We know we need n always. We know that we need p hat. We know that we need q hat, okay? We know we don't need standard deviation for proportions. This is like, what percentage of kids do this, right? We don't need a standard deviation for that. And then we need to know what z is, okay? That's the variable that we use. And then we calculate from that information, we use that to find the error, okay? And we have a formula for finding error, okay? Do we need to write out what n and p and q and z are or not? Okay, I'll write here like n is the number in the sample. P hat is I'm going to say like the proportion, whatever we're talking about. So like this percentage of kids do this thing, right? Okay, Q hat is 1 minus P hat. Okay, that's something that we have to solve for. Z, this is the chart lookup. Okay, so we look up the numbers in the chart, right? So maybe Z is like the 1.645 or 1.96, and that's on the Z chart, right? It's the one that has like positive side, right? We use the positive side of that positive negative chart. You know what I'm talking about, okay? We use the positive side down in the corner. We use that depending on which confidence interval we have. So 90%. 95%, etc., 99%, whatever, right? Whichever one that we have, okay? All right, E, after we have that information, we do Z times the square root of P hat, Q hat over N, right? Z is, error is Z times the square root of P hat, Q hat over N, okay? And then what we do with that is we add and subtract that error to get our confidence interval. So we're looking to find this number and we're looking to find this number. What variable do we use in the middle? Like what are we estimating? P, right? And P stands for the population one. P hat is the sample, but P is the population. We're trying to determine what the population number would be, right? Okay, so given my sample, this happens, how is that in compared to the population? And we find those numbers, okay? So how do I calculate these numbers over here? You add and subtract the error from what? P hat, right? P hat is my estimate for the sample, so I'm going to subtract the error from that, and P hat is my estimate for the the sample on the tall end. I'm going to add that, okay? All right, so that's what we are interested in finding, yeah? Okay. All right, I'm going to do my example over here. So, and I'm going to make it so that like P is kind of hidden. I'm gonna kind of hide the P hat because sometimes when this happens, it's a little bit harder to do. So I'm going to give you the hardest example just so that we're clear, okay? So my example is going to be that, what should we talk about in this class? Sports. Who does sports? in here? 1, 2, 3, 4.
TJ does too.
TJ 5. Who else? Ellie, Maddie, Indy,
Lily.
Michelle,
Lily.
Lily. That's 5. Oh heavens to Betsy. 5 plus you 5. So let's say 10 out of 17, right? 10 out of 17 do sports.
Oh, are you videotaping this?
Yes.
Okay.
Yep. 10 out of 17 do sports. Okay? In this class, 10 out of 17 do sports. I don't know. It might be 11. It might be 12, whatever. But we'll just say 10. 10 out of 17 do sports. I think that may be accurate. Okay? So I'm going to say use this to estimate the proportion of all seniors that do sports. Okay, I don't even have a P there at all. Like P is percentage. P is a proportion. I don't have that yet. That's kind of messy. Yep, so P hat, that is kind of hidden. And we do 10 divided by 17 to figure out the proportion, right? Okay, proportion of seniors that do sports. 10 divided by 17, somebody have that for me? I don't have a calculator. Oh, I do, right here. 10 divided by 17. You might get it faster than me. I'm going to do 0.59. We'll go 2 decimal places. So that means 59% of you guys do sports, okay? Now, if I include all of the seniors in Blue Hill, all of the seniors, is it true that 59% of all of the seniors do sports? No, probably not, because some of those other people might do, they might all do sports, or they might not do sports, none of them. So it'll just change that percentage. So it won't be exactly 59%. So rather than saying definitively 59% of all seniors in Blue Hill do sports, we give a range, right? And we say somewhere between this number and this number do sports, right? Does that make sense? And to do that, we figure out what the error is, okay? So we know P hat is 0.5. So let's figure out, let's write our variables over here. N, P hat, Q hat, Z, and then we need the error. Okay, what's N gonna be?
17.
17, that's my total number in my sample. P hat we just found was 0.59. Q hat.
It's 1.41. Yeah.
1 minus that, so 0.41, 0.41. Okay, and then Z. Hold up, I didn't give you some information. We need to know what confident interval we want, right? The more confident you are, the wider the range is, right? Have we talked about that? If you want to be really confident about your target, you're going to make your target really big. If you want to be less confident, like 80% confident, you're going to make your target smaller, okay? So let's do, I'm going to add information into here. Use this to estimate. I'm going to say at 95%, okay? The proportion of all students that do, or all seniors that do sports. So I had to give you the 95%, and I didn't do that. So just add that in there. Okay, if we're doing 95%, how do I figure out what Z is? The bottom corner, right?
Yeah.
The bottom corner. Is it 1.96? Yeah, 1.96?
Yeah.
Okay. These are numbers that you've seen before, right? Like you're used to saying 1.96 or 1.645 or whatever, okay? The error now is what we have to calculate. So we do 1.96 times the square root of, oh boy, P hat is 0.59 times Q hat is 0.41 all over 17. And we calculate the error. Mm-hmm.
Is this the one where we have to square it?
No, that's the next part. That's when we're solving for n. Yep. Well, you do have to find the square root though.
Yeah.
Yes, square root. Okay. So it wouldn't hurt to practice typing that in, so that you are prepared for that come test time.
0.23.
Point what?
0.2338.
That's a big error. 0.24. We'll say that's a large error. How's come my error is so big? Do you know what makes your error so big?
Not a lot of variables.
not a lot of people that we're sampling, right? That's kind of the way it goes. One goes up, the other one goes down, right? And vice versa, okay? So the fact that we only have 17 people, whew, really makes that a big number. So 24% is my error. Yikes. Yikes. So we can say that the proportion of students at Blue Hill, or seniors at Blue Hill, that do sports is anywhere between something and something, right? We take 0.59 and we subtract 0.24, and we take 0.59 and we add 0.24, right? Holy cow, that's going to be crazy. 0.59 minus 0.24, 0.59 plus 0.24. I can do the plus. That is 0.83. 83%. I can do the minus 2, 0.35. Is that right?
Probably.
So now I'm going to go down here to this next box because we're not going to need all of these boxes to the next one. And we're going to do our interpretation of this. So we can say we are 95% confident that what?
At between 35% and 83% of seniors play sports.
That between 35% and 83%, I'm going to add one word, of all seniors at Blue Hill play sports. Okay? Because what we're trying to do is we are trying to use these numbers to estimate the population. So we're talking about all seniors rather than just the seniors in this room. Does that make sense? Okay? Now, that was a really big range because my error was huge, okay? So I'm going to go down to this next box and we're going to estimate, like, how many seniors would I have to survey in order for my error to go from being 24% down to, let's say, like 10%, okay? So I'm going to pose that question over here. I'm going to do one of these. Can I do one of these? Just to show that those go together, right? Okay. All right. How many seniors for only 10% error? Okay. If I want to bring my error down from 24% to only 10%, how many seniors do I have to survey? Is it going to be more or less than 17? If I want my error to go from 24% to 10%, do I have to survey more than 17 or less than 17? More, because I'm going to be more accurate, right? So we know it's going to be more. And there's a formula to finding the N. So important information, I'm going to put my formula here. N is equal to, and this is just this formula right here, but switched around to solve for N, right? Okay, so it's not something that we haven't done already. N is... I'm going to give it to you here in a second when I find the N. Oh, but you know, where is it at here? Right here. Here we go. N is, you have a mess here, child. Yeah, you're fine. You're fine. P hat. Q hat. I could just figure this out maybe in my head, but whatever, it's fine. And then E over Z squared. Yeah, something like that, right? I'm going to add one thing. I'm going to say still 95%, because I have to give you the percentage, the confidence percentage. So we're going to say we're still at 95%, okay? All right. Do I need to put my variables over here? Like what N and P hat and E and Z are?
Nah.
It's the same as what's above, right? So same variables. Okay, I'm going to put here estimating sample size, which is N. That's what we're doing in this problem. We're estimating the sample size, which is N. And this is still for proportions, so we're still under that same box for proportions. Woo, that's a lot of stuff. We haven't even solved the problem yet. Okay, let's do it. N equals 0.59 times 0.41 over, I want to be within 10%. So what do I use for error?
10, 90,
You're close.
85.
I want to be within 10%, so what's E?
10.5.
0.1. We have to convert it to a decimal, right? 0.1 over z. I'm still going to use that same z, 1.96, and then we're going to square it. And it's going to tell me how many people I have to survey.
I hate this.
Okay. Right.
Good. I hope it was.
I got. Did you get 92.9?
Hold on, I'm almost done. Yeah, that's what I got.
Okay, now 92.9 does in fact round up to 93, but even if it was 92.1, you always round up, right? Always round up. So this is going to be 93 seniors. We don't even have 93 seniors at this school, but if I want to be within 10%, I've got to survey a lot more people, right? Okay, as error goes down, the number that you sample goes up, right? Or and vice versa. Okay, that's just the way that it works. Are we happy with that? All right. The mean box is going to be similar to this. We're going to do kind of the same format going down. Okay, ready? I'm going to section him off. No, let's use this color. Sectioned off. Okay, all right, moving on. Mean. All right, we need for mean, we need to know what n is. We need to know what s or sigma is. We can use those in the same spot. Okay, n, s, we need to know. I need a new paper. I'm trying to make it so I don't have to end up erasing and then making all the people in the video say, right? Because I know they're going to. Okay, we need to know what T or Z is, and we got to figure out when we use each one, right? T or Z. And we have to figure out the error. Let's see how I did this up here. T or Z. Okay. Yeah, let's do that. Error. We use that information to calculate the error. Okay. All right. Do you know when you use T or Z?
Yeah, on our sheet.
What?
It's on those sheets.
It's on your sheet. At the top of the T chart, it tells you when you use that guy versus when you use Z. Should we put it on this chart also or not?
Yes.
Yes? Okay. You use T when N is less than 30. Really, that's kind of the main thing, I guess. Or when you only know S. Those two requirements in order to use T. Okay? You use Z when N is greater than or equal to 30. And I'm going to say or you know this guy. Okay? That's when you use each one of those. Okay? So if you have your N is less than 30 and you don't know the population standard deviation, you use T. If you do know the population standard deviation, which is this guy, you use Z, or if N is greater than 30. Does that make sense? Okay? All right, calculating error. Here's our formula for calculating error. We have, I'm going to do T. I'm going to say or Z, because it depends on what you're using, right? And then we have times S, I'm going to say or sigma over the square root of N. Okay, there's only 3 numbers that you're going to use, but if you need to use Z, you use Z in place of T. If you need to use sigma, use sigma in place of S, right? Does this make sense at all? Clear as mud? Clear as mud? What? It's as clear as mud? Okay, what else did I write down? Up here?
Stop, don't move.
Nothing. I'm just looking to see. I'm trying to stay consistent here. Kid, you're killing me. I know. Okay. So we're estimating mean. What's the symbol that we use for mean right here in the middle? What symbol do we use for mean?
Mu.
So we're gonna use the. Oh wait a second. We need to know X bar. Shoot. X bar. Sorry. Add him to your other column. We need to know X bar. He's important. Okay. But mu is the one that we're estimating. Mu is the population. X bar is just the sample. So population. And to find out what these two numbers are, after we found our error, we're going to add and subtract. So we subtract the error, we add the error, but what do we add it and subtract it from?
X bar.
The X bar, right? That's when we need him. X bar, X bar. And that's how we do that confidence interval. Okay? Clear as mud? Happy with that? Nothing you haven't seen before, right? Let's do an example.
Don't slide too far.
I won't slide too far.
Thank you.
Example. What should we talk about? Averages.
People wear glasses. That's great. You're average.
We could do people that wear glasses, but that would be like a yes/no thing. We could do proportion for people wear glasses, right? But we need like an average. So what did you say?
No.
Height? Yeah. We could do height. You want to do height? Sure. I'm sorry, Indy. She's moaning and groaning right now. Height. Okay. So
She watched.
I'm gonna say average height for 17 seniors is how tall? I don't know.
7'1".
Right. Average height is, I don't know, 5 point. How tall? What's average? 5'7". We're tall in here. 5'7". Okay, but what is 5'7"? 5'7" as a decimal. We do 7 out of 12, right? That is 5.58 feet. That's what 5'7" is, right? 5.58 feet. You see what I just did? Okay. All right. That's the average. Okay. And we need a standard deviation with standard deviation of, I don't know, 0. Let's say 54 feet. So like 6-inch standard deviation. That's kind of big. Oh well, we'll see what it does. 6-inch standard deviation. Whatever. We'll see. I don't know. I don't know, folks.
Height down.
Should we do a less standard deviation? Let's go 3-4. Can we go 3-4? I'll change it. I'm gonna just hush. And the people on the video are yelling at me too. 0.34 feet. We'll go 3-4 feet. Okay. I know they should. All right. Find. Should we do a 90? What should we do? 99% confidence interval
Sure.
of the mean. Okay. Find a 99% confidence interval for the mean. Okay. All right. Things that we need. I just start listing out variables from here. So we know we need n. We know we need x bar. We know we need s. We know we need. Are we needing t or z in this case? Which one are we going to use?
T,
Why t?
because it's less than 30.
It's less than 30, and
And
we have
don't
s
know.
and not sigma, right? Okay, so we need to use t in this case. All right, at 99%. All right, so what's n?
17.
17. X bar? 5.58. Standard deviation, 0.34. And t. Okay, so make sure you're looking up the correct chart. The t chart. I don't even think I have one. The t chart is the one with the square-ready things, or the bell curvy things on the one side. Over here. And
2.120.
so, wait a second. Degrees of freedom. What will my degrees of
16.
freedom be? 16, right? So, I'm going to put always 1 less than n. If you need to put that in there. If you don't need to put that in there and you remember degrees of freedom is n minus 1, don't put that in there. 16, and we go over to 90, which one? 9%? I don't know, my chart is not right. 2.921. 2.921, is that what you said, Molly? Okay, 2.921. All right, here we go. E is 2.921 times S over the square root of n. Square root of 17, S is 0.34. And then we calculate the error. And we get something. Let me have it yet. I'm working awful slow right now. 0.34. Wouldn't hurt to type it in. To practice typing it in. I got 0.24. Somebody else said that already, maybe? Oh, come on. Oh, come on. 0.24? Yeah? Keaton's shaking her head back there. You didn't get that, Abigail? Did you put a decimal in the wrong spot?
Yeah, 0.24.
Or did you put parentheses in the wrong spot?
I didn't put parentheses.
Maybe. 0.24. Okay, so see, yeah, you check and see what you did, and if you still can't figure it out, I can help you. So we add and subtract. 5.58 plus that, and 5.5 minus that over here. Good heavens. Minus and 5.58 plus. Okay, I can't do math. Plus 5.58. 5.82 and 5.34. Okay. All right, so let's interpret. You help me in this box. We are, start with that. We are what?
99% confident.
99% confident that, oh, I'm going to say confident. CONF. That what? That, what about all of the seniors? The average height of all BH seniors is what? Between, yeah. 5.34 feet and 5.82 feet. Now, there are some of you guys that are 6 feet and you are not counted in this. But we're not talking about you fitting in that interval. We're talking about the average of all of you fitting into that interval. Does that make sense?
Hey Jackson, you're not above
Okay.
6 feet.
What?
Jackson's out of this.
So Jackson is bringing the average closer to this range, right? And that's okay. It's all right. It's fine. What? You still what? You still didn't get it? Hold on.
Try taking it multiplied factor
You're a funny guy, Dylan. You're a funny guy.
I know.
You want to do what?
You typed it in right.
I know I did.
What did you
You're a
do?
funny guy.
What happened to him?
Obviously.
My calculator's
I know. He's just
No,
being
it's
angry.
close.
MJ,
Oh.
who did Cordy play last night?
She went 9 to
Who?
1.
How's Isaac wrestling yet?
Yeah, Isaac and Aiden both lost.
Yes.
And
And you're not
Carter's wrestling right now. and
There
he's
you
losing
go.
by-
We got
Isaac
it.
and Aiden both
Perfect.
lost.
Okay.
They don't wrestle till tomorrow.
Okay.
All right.
But
All right.
Carter right now is wrestling, and Isaac said he's probably gonna lose. He's getting beat by
Like what grade's the other kid? Do you know?
Oh, what grade?
Yeah.
Oh, I don't know.
I
I know he's a
wrestler
first seed.
sophomore.
I know he's
Okay. We'll do this box and then we'll say variance and standard deviation for tomorrow. Okay?
Oh, yeah.
All right. Do this box and we'll save variance standard deviation for tomorrow. I'm going to give you guys your reviews though, so you can look those over. All right. Now we're going to say that how many seniors do we have to survey for? What was my error before? 0.24. How much of an error do we want now? For error. Woo.
Should do it
You
bigger.
want a 5%
Bigger.
error.
Yeah, let's go. Error of only what?
5.
Now we're not doing 5% though. These aren't percentages.
I know.
0.24 was my error. What is the units on 0.24, by the way? That's the error. Feet, right? 0.24 feet is how much we're adding and subtracting, right? So we want to only be off by like, let's do only 0.15 feet. What's 0.15 feet? 0.15 times 12. That is an inch, 1.8 inches. Let's do this. Can I erase? I'm sorry. Don't kill me. Let's go 2 inches. of only 2 inches. Okay, how many seniors do we have to survey in order for only a 2-inch error? Now, we have to convert that to feet. So 2 inches in comparison to feet is 2 divided by 12, which is, I should have known that. It's 0.1, let's go 0.17 is my error. So we're only having an error of 2 inches. I want to know that interval, right? How many seniors do I have to survey? Here's your formula. N is equal to
How much did Isaac lose by?
15-2.
N is equal to Z times standard deviation over
So he's crying.
E squared. There he is. Z times standard deviation over E squared. Okay?
Okay.
All right. N equals, we're still at 99%. So the Z that we're going to use, and this time we use Z, right? How come we use Z and up above we used T?
Because we want, I don't know.
In order to use T, we have to know how many degrees of freedom. And in order to know degrees of freedom, we have to know N. But we're solving for N, right?
Yeah.
So we have to use Z. So in this case, Z at 99% is, I don't know, 2.575. Check.
What? Oh.
Z at 99%. 2.575, I think.
Yes.
Yep, 2.575. Okay. So it has to be Z and not T when you're finding N, because you can't find T. Standard deviation is same as up above, 0.34. And all over the error, which is 0.17. How many seniors do we have to survey in order to have that happen?
Oh, gosh.
That's not too bad. That's doable.
26.5.
26.5. So
27.
27 seniors.
It's not doable here.
Right, it's not doable here, right? But yeah, that's not too bad. Okay, happy with that? Okay, let me give you your reviews. I'm gonna shut the video off. Goodbye, people. We'll do variance standard deviation tomorrow.